My name is Mohammed Abdullah, and I'm from the Hasselblatter Institute. This layout is produced by Roadkill, a software tool that lays out Lasercut 3D models so that matching parts are adjacent. This allows Roadkill layouts to be assembled 2.4 times faster than traditional layouts. If we build a chair model using the traditional laser cutting workflow, it would take a long time to model the individual plates. Then cutting is really fast, and then assembly would take some time. But with software like FlatFab and Cube, modeling for laser cutting has also gotten fast. And what we see now is that the step of assembling, which was previously negligible, becomes the bottleneck. To further speed up the process, we need to increase the assembly speed. There are two steps in the assembly process: searching for the right parts and then joining them. Here's the typical method to help users find the correct plates. Lookup numbers are engraved on pairs of edges, and the user has to perform a quadratic search to find the corresponding numbers. So what we saw here is that plate search scales quadratically. As the total number of plates increases, it will take increasing amounts of time to find the right plate. But once the user finds the right pair of plates, joining them is a linear process. So to really speed up assembly, our objective is to minimize plate search. Roadkill achieves this by creating layouts based on 8 design elements. Roadkill creates a preview thumbnail to indicate which part the user is assembling, in this case, the bottom of the chair. Roadkill indicates starting plates with exposed finger joints. Plates can be inserted from above into cavity-shaped jigs. The user continues by inserting into the immediately adjacent plate. And then follows the arrow. Now we see that the next plate has no further neighbors. So the user continues with another plate that has exposed finger joints. This subassembly is now complete, and the user inserts it into position indicated by the matching label. And now the user follows the assembly order and continues with subassembly 2. In our user study, participants assembled this model in around 10 minutes and were on average 2.4 times faster than assembling a traditional layout with engraved numbers. Roadkill achieves this by maximizing adjacency while minimizing numbers. While Roadkill eliminates the need to search for individual plates, it introduces the need to search for subassemblies. The reason Roadkill works is because it replaces the search for many parts with the search for very few subassemblies. The Roadkill algorithm thinks of assembly as the reverse of disassembly. Roadkill starts by disassembling the plate that has the highest number of connections in the model. Roadkill then removes the plates that were connected to the previous plate while making sure that all of them can be removed independently of each other. Roadkill repeats this step till all plates are part of the disassembly tree. Next, Roadkill makes sure that all branches of the tree can be assembled independently. In this case, the brown plate is blocking the true branches. Roadkill resolves this by making the branches subassemblies of the blocking plate. This makes sure that the user will assemble them and connect them to the blocking plate before the next step. Next, Roadkill creates the 2D layout by placing connecting plates adjacent to each other. Roadkill then resolves overlaps by either linking through arrows or creating further subassemblies. For more details, please look at our paper. Finally, we integrated Roadkill into the export pipeline of Cube, a 3D modeling software for laser cutting. To validate our design, we conducted a user study. We recruited 12 participants Each participant assembled both the roadkill and the traditional layouts. We found that on average, users assembled roadkill layouts 2.4 times faster than traditional layouts. To understand how this performance benefit came about, we downloaded the top 60 models from the Cube repository and ran the roadkill algorithm. The test models were made from 1 to 100 plates, which roadkill organized into 1 to 25 subassemblies. We found that the number of subassemblies roughly scaled linearly with the number of plates, and on average, roadkill grouped 5 plates into one subassembly. Roadkill replaces the time required to search for plates with visual search for subassemblies. Given that plate search has quadratic complexity, this reduces the user effort by a factor of 5 squared, or 25 times. So in conclusion, roadkill minimizes plate search, speeding up the assembly process, and in turn speeding up the entire laser cutting workflow. Zooming out, the objective of roadkill is to accelerate rapid prototyping by another step. Before the introduction of fabrication technology, one might have outsourced the creation of a chair model like this one to a craftsman. The introduction of 3D printing and laser cutting allowed doing this in-house. My objective is to speed up prototyping to the point where it can be performed within the time frame of a meeting. I would like to thank my collaborators for the time and effort they spent on this project, and I look forward to discussing this work in the Q&A and at the demonstration.